This video is about zoning for lighting in energy performance of buildings calculations. This video has been prepared by the EPB Center team in the context of a service contract for the European Commission. This video is part of a series dealing with the basic concepts of energy performance of buildings. This example is about a building with lighting zones, but zoning principles are the same for all technical services. Most buildings do not have the same conditions evenly distributed among the building. Therefore, we need to split up the building into parts. For each part, the energy ins and outs are calculated and in the end assembled. This dividing is called zoning. Zoning has two basic layers, the thermal zones and the service areas. A thermal zone is an internal environment with sufficiently uniform thermal conditions to enable the thermal balance calculation. This includes indoor temperature and humidity. For the calculation of the overall energy performance, combine as much as possible spaces into one single zone. By preference, one thermal zone per building. In this example, we have two thermal zones. Default rules are given where and when partitions are needed, and they can be replaced by national rules. A service area is part of a building consisting of one or more spaces served by a specific technical building system or subsystem. There are lighting service areas marked as SAL with a number, like here. Heating service areas marked as SAH with a number. Cooling service areas SAC, ventilation service areas SAV, etc. In this example, there are 4 lighting service areas. Each lighting service area has different energy properties for lighting, but within one lighting service area, it is more or less the same. Note that service area can be part of a room, see SAL3. The boundary of a service area does not need to be a material boundary. So you can split the room into a zone where the lighting will always be on and a zone with a present deflection. Also, you can combine adjacent rooms, as in by service area 4. So a group of, for example, 6 office rooms can have 2 lighting service areas, one for the daylight zone and one for the artificial lighting zone. Note that the division is based on the energy needs or use of the lighting systems and not on the illuminance level or any other lighting property. Although there is, of course, a relationship. For example, a corridor can have a lower illuminance than classrooms or offices and therefore have a lower energy use and therefore be in a specific lighting service area. For the calculation of the overall energy performance, combine as much as possible spaces into a single service area. Default rules are given when and where partitions are needed, but they can be replaced by national rules. The same goes for other service areas, for heating, cooling, ventilation, etc. Each of the divisions is separate from the other. This has a big advantage. If you have a refined partition for one service, you can still keep the division for all other services simple.
then we can start the calculations. For example, dissipated heat from lighting. From each lighting service area, it is allocated or redistributed to each of the thermal zones, with simple rules, for example by weighted floor area or perhaps by weighted volume. In the example, the heating from the lighting in the lighting service areas 1 and 2 are completely allocated to thermal zone 1. And the lighting service area 3 is completely allocated to thermal zone 2. But lighting service area 4 is divided between thermal zone 1 and 2. And this is done by the weighting of the floor area. So I would say 1/3 to zone 1 and 2/3 to zone 2. In the same way, the heating from the heating services and the heat loss from domestic hot water can be distributed from their own service area, that can be bigger or smaller, to the thermal zones. And from there, the energy performance calculations of the thermal zones continues. And we can be sure that the heat contribution from all systems is taken into account in the right way.
More information can be found in the following energy performance of buildings standards. EN ISO 52000, Part 1, where the overall zoning rules are given in Chapter 10. Part 2 is the accompanying technical report to the standard. It gives explanation and more examples in its Chapter 10. Then EN ISO 52016, Part 1, gives specific rules for thermal zoning. Note that there is a spreadsheet available with an example on the EPB.Center website. In other EPB standards, you can find zoning rules when applicable for the specific service systems. Thank you for listening. This video has been prepared by the EPB Center team in the context of a contract with the European Union represented by the European Commission. The information and views set out in this video are those of the authors and do not necessarily reflect the official opinion of the European Union. Neither the European Union institutions and bodies nor any person acting on their behalf may be held responsible for the use which may be made of this video or the information contained therein. Check out the other videos dealing with the basic concepts of the energy performance of buildings that can be found on the EPB.Center website. Thank you.